Lesson 4 of Unit 7. We're going to be solving logarithmic equations and inequalities. This is really probably going to be a very easy lesson for you. It's pretty straightforward, and let's just kind of dive right in. So the first thing we're doing is just going to dive in with an example, and because this example is really similar to stuff that we saw in the last lesson, at least at the beginning of the last lesson. So we're supposed to solve this equation. And in order to solve this equation, all we really have to do is convert this from logarithmic form to exponential form, right? So we're going to turn this from log base 36 of x equals 3/2 to 36 to the 3/2 equals x. And then we can do 36 to the 3/2. We can do that. We can do that by hand. We can pop it in the calculator. So remember, this is the square root of 36. Whoops. The square root of 36 cubed, right? The bottom one is the root, and then the top one is the power. Square root of 36 is 6. So 6 cubed. What is 6 cubed? 6 times 6 times 6. So 36 times 6, whatever that is. Let me grab my calculator and see what. All right, so 6 cubed is 216. So x equals 216. Easy peasy, right? No big deal. Let's hit the next thing. So property for equality of logarithmic functions. So this is just like the property of equality for exponential functions that we learned before, where like if we have like bases, so a or b, we'll use the same letter here, b to the x, if b to the x equals b to the y, then x equals y. So it's the same idea. If you have the same base, then you can set, instead of the exponent with logarithms, because the focus is different, right? Instead of the exponent, we can set the arguments equal. So if the bases are the same and they're equal, then we can just set the arguments equal. Let's do an example using this, right? So here we have solving this. Log base 2 of x squared minus 4 equals log base 2 of 3x, right? So since the bases are equal, we can just set the arguments equal. So the log base 2 part can just kind of poof away, right? So this can turn into x squared minus 4 equals 3x. Now we've got a quadratic, right? Because we got this squared term. So what are we probably going to do? Well, it's going to look, we've got 1, 2, 3 terms. It's trinomial, so we're going to hope that it factors. So if we're going to factor it, we're going to first get everything on one side and 0 on the other side, right? So we're going to start by subtracting 3x from both sides, minus 3x minus 3x. This cancels and turns into 0 because 3x minus 3x is 0. So we've got 0 left on this side. And then we're right in descending order over here. So it's x squared minus 3x and then minus 4. Watch those signs. That's an easy place to make a mistake. So can we factor this? 2 sets parentheses equals 0. X times x gives us x squared. How about 4 and 1? 4 and 1, and then we're going to do our smiley face. We've got 4 times 1 is 4. 1 times 1 is 1. Can we add or subtract those to get negative 3? Yes, we can. Negative 4 and positive 1. Follow our nose and put minus. Follow our mouth and put plus. Double check that last sign. Negative times a positive is a negative, so this works. So now, of course, we set each factor equal to 0. So x minus 4 equals 0 and x plus 1 equals 0. Then we would add 4 on this one and subtract 1 on this one. Excuse me. Because, yeah, so we end up with x equals 4 and x equals negative 1. Now, we would like to just circle this and move on with our life, but we need to check our answers to see if they work. Why do we need to do that? Well, we need to do that because if you remember from last lesson, logarithmic function, both of them start over here. They never quite get to 0. So x on a logarithm cannot have a negative or a 0 number, right? We have we have to say greater than 0. So if it's not a positive number, then it's not going to have a solution. So we need to make sure that we can make this, we can double check and see if this works. And let's double check and see if we end up with taking a logarithm of a negative. Now, you might be like, well, this is already negative. Just throw it out. Kill it stone dead. Well, spoiler alert, we are going to kill it stone dead, but major but here, it's not because of this negative. That's not it. Okay? It's if the entire argument turns negative. So you can have a negative number as a solution to this problem, but the whole argument cannot be negative, right? Okay, so I already gave I already let the cat out of the bag on what's going to happen, but let's check them both. So the log base 2 of 4 squared, which is 16. That's just this. And then minus 4 equals, does that equal the log of 3 times 4, right? So 16 minus 4 is 12. So the log base 2 of 12, does that equal the log base 2 of 3 times 4? Yes, it does. Log base 2 of 12 equals log base 2 of 12. It's positive. It's great. No problem. Now, this one, we already know it's not going to work because I already spoiled the ending. I'm sorry. Should have given you a spoiler warning, but, I'm going to move this over here, though. All right. So, but in our notes, let's make sure we do this so that we can know what happens. Make sure you're doing that all in the notes. That way you'll know what happens later when you're trying to remember for your homework or studying. So the log base 2 of negative 1 squared. Negative 1 squared is negative 1 times negative 1, right? So that's positive 1. 1 minus 3 equals, you can already see an issue there, I hope. And then the log base 2 of 3 times 1 is negative 3. So we're already in a sad place. It doesn't work. So sad, right? Oh, I copied that wrong because I was thinking about the future and not the present. Oops. That should be a 4, right? So the log base 2 of negative 3 does, in fact, equal the log base 2 of negative 3 in that they're both undefined. So this one we're throwing out because of this. Because this is negative. Not because this is negative, right? So X can be negative, but the whole argument can't be negative. I can't stress that enough. That'd be an easy way to just make a mistake on something that is not difficult, right? So next thing is property of inequality for logarithmic functions. So this looks like a lot of mess. It's not really very complicated. All this, in its core, all this is really saying is that we can convert between logarithmic form and exponential form with inequalities the same way we can with equalities, right? And that's really all we're saying. So we can turn this into this. Now, what is all this hoopla of these two different conditions? If b is greater than 1 and log base b of x is greater than y. So what that would be is b to the something if this is a great number greater than 1, so 5, 6, 2, 34, right? Anything that's greater than 1, if we raise it to a power, then the whole logarithm is going to be bigger, right? So if that's true, this that way. Now this one and this, excuse me, this one is kind of one of the real reasons why we need this this slide, essentially, because we're not going to have a number less than 0. You can't have a negative down here because that breaks our domain issues and all of those things, right? So between 0 and 1, if b is between 0 and 1, so if it's a fraction and we raise it to a power, then it's getting smaller, right? And I can illustrate that because in case you're a little confused on this one. So like if I have 1/4 squared, that would equal 1/16, which is a smaller number. So that's why it's arranged this way and all of that. Let's do an example and then we're going to be done. This is going to be a pretty quick one for us. All right. So we're going to solve the log base 3 of x is greater than 4, right? So just like we did on the very first example in this lesson, all we really have to do is convert this to exponential form, right? So we're going to convert this into 3 to the 4th is greater than x. Yeah, we want to do that if we're like making a mistake, right? That's not how that goes. That's not how that goes at all. Try again. How about x, the argument, is greater than 3 to the 4th? Because that's what the property we just learned says, right? So x is greater than 3 to the 4th. What is 3 to the 4th? It's 81. So x is greater than 81. Blammo. We did it. Great. Let's do one more example, which I forgot to copy in here. So let me pause and write it and do it. All right. I also forgot to write a property on here, but the property is simple enough and fits with everything else so well that I'm going to teach you the property and do this example all in one. So you can see you can probably just look at this and tell me probably what we're going to do, at least a part of it. There's one thing that we need to do because this is logarithms and we have a restricted domain and all of those things, which I'll talk about in a second. But the core bit here is that if we have log with base b, whatever base it is greater than or less than log base b, so the bases have to match, then we can remove the logs and basically set this greater than or less than or whatever it is to this and then solve it just like we always would. Excuse me. So let's do that. So this, because the bases match, we're going to turn this into x plus 3 is greater than 2x plus 1. So just like with an equation, with inequality, you can basically just draw, if the bases match, if they match, you can basically just drop off the logs and set the two arguments equal to each other, or in this case, greater than each other, right? So that's the property. There's one more thing that we're going to see here in a second in this example. So let's solve this guy. Excuse me. Let's go ahead and solve this guy for x. Okay, so let's do, we could do this a couple of different ways. We could subtract this way or this way and then flip it again in a minute. Let's go ahead and subtract x from both sides. Why not? Then we'll keep our x positive. We could move x this way as well. We would just have to remember to divide off a negative. We're also going to have to remember something else in a second, but we'll get there when we get there. Because we're in algebra 2, let's also go ahead and subtract 1. So we're moving this x this way and moving this way, minus 1. That way we can kind of just hit all the things we need to hit. So 3 minus 1 is 2. And then we still have this greater than sign. And 2x minus x is x. Now, I like, especially on an inequality, to flip this around where the x is on this side. But remember, if you flip these two sides, you have to make sure you flip that inequality to go with it, right? That's very important. So x has got to be less than 2. Now, since this says x has got to be less than 2, we eventually are going to hit a wall, and we don't want it because we're going to hit that asymptote, right? We've been running into that all over the place on this lesson. So we also need to know whenever these arguments, we have to exclude everything where these are going to be negative, right? And so let's do a couple of little inequalities for the arguments here, because x plus 3 has got to be greater than or equal to 0, and 2x plus 1 has got to be greater than or equal to 0, right? Because if either one of these come up, then we've got a domain issue, right? So let's take and subtract 3 on this one, minus 3 minus 3. Let's subtract 1 on this one. So this cancels. So x has got to be greater than or equal to negative 3. Excuse me. Right? And then this one, we've got 2x is greater than or equal to negative 1. Then we're going to divide off this 2. Divide off this 2. X has got to be greater than or equal to negative 1/2. So we're going to write this as this whole mess as a compound inequality. So what is the lowest number that x can equal? Well, it's actually just this one, right? Because if we're thinking about a number line, right? We've got a 2 over here. It can't be greater than that, so it's got to be this way. And we're going down here, and we hit negative 1/2 over here, right? Negative 1/2, and we can't go farther than that, right? It's got to be, it's got, excuse me, it can't be any lower than that, right? Easy peasy. I don't know why I'm putting equals to. Y'all aren't here to stop me and be like, wait, isn't it supposed to be? Yeah, you're right. It's not. Yeah, you can't have a 0 either, right? That's not going to work because it gets closer and closer to 0, but never gets there, right? So how about open circle if we're kind of graphing this? Now, if we're trying to keep, it's got to stay less than 2. We already stopped there, so we can't even get to the negative 3 part, right? We can't even, so the negative 3, while true, it's irrelevant, right? It's not helpful. So it's got to be between here and here. So our answer is that x has to be between negative 1/2 and 2. There we go. And that's it for solving logarithmic equations and inequalities. This one was pretty straightforward. The next one is really fun, where it starts to get fun, in my opinion. I may have said that last time because I was thinking about the next lesson and not this lesson. This one's like easy. This one's like simple stuff. The next one is not much harder. We learned some properties and how to manipulate some equations, and I think it's fun. We'll see what you think. We'll see you later. Don't forget to like and comment, subscribe, all the things. See you later. Bye-bye.